Does anyone have any questions? Okay.
She's been itching, I can tell.
First for Dan, AIAA has a space colonization technical committee. You have a TC for space. Oh, I'm sorry. AIAA for. Is it going? Yes, sort of. Okay. It's a very good mic, not much echo. Yeah, AIAA for Dan. AIAA has a space colonization technical committee, TC. We find that in AIAA space conferences like Space 2018, of course 2017 didn't happen because of Hurricane Irma, usually the only future or the rare future-related presentations are actually in the track that the Space Colonization Technical Committee presents. Plus, there's not going to be an AIAA 2019. It's going to be combined into IAC. I'm not sure there's a question here, but the Space Colonization Technical Committee has been trying to get a lot of traction with AIAA about let's look to the future, and we haven't really gotten a whole lot of response from headquarters. Can we kind of change that and get more interest from headquarters? Whoops. I did that for you.
Here you go.
There you go.
So first of all, is this on?
There's probably a power button.
There probably is.
There you
Now I am. So the quick answer to that is actually yes, we need to fix that. Let me try to highlight, go into a little bit more detail on a couple of things. Number one, you're correct about there is not going to be a Space 2019 per se. However, we are adding a day for all the space tracks at the Propulsion and Energy Conference, or Propulsion and Energy Forum, that will occur in late August. It's going to be really handy because that Propulsion and Energy Forum is in Indianapolis in August. So that would be an opportunity. I would highly recommend the IAC activities, particularly for 2019. I think the call for papers is already out. We're going to also push that out through the AIAA loops. But IAC, for everyone, is in Washington, D.C. in 2019. So, did it turn off?
That's no better.
Oh, now I can hear myself. Can you hear me now? So I would suggest that you guys look at all of those opportunities, but to your basic point, I think, there it goes again.
Probably low in power.
Yeah, now it's got a red light. But that's okay, I'll go into basketball coach mode if I need to.
Yeah, why don't you try this? We'll just-
No, you don't want to use that one, Larry. You, the Space Colonization Technical Committee is looking in but we also want to expand that thought process across all the other applicable technical committees. One of the things you're going to start to see AIAA talk about that relates to this is an overarching theme on building the space economy and what do we need to do for the future. So all of this plays into that. We're starting to work how we can align the technical committees, which TCs do we need to pull in, frankly, which local sections, which student chapters do we need to pull in or want to engage. So we're going to try to broaden this out. The Board of Trustees for AIAA just agreed with our overarching themes back in August, and we're just now in the process of starting to get that out, and this is one of the first steps.
Okay, thank you. SCTC is willing and waiting to help.
And we understand that, and please we're going to keep pushing it. We'll get it done.
Yeah, a couple of you have alluded to it, and I wonder what the relevance is to this workshop. Question is about how to divide up the work. I mean, there's a huge amount of research and development that needs to be done, and as you pointed out, Larry, NASA has kind of raised its hand and said, well, we're going to lead. We do that. But this is a worldwide effort, as you pointed out, and it's an effort that requires both a combination of national agencies, private industry and universities, maybe something else. So how does that tie to the effort that needs to be addressed in this workshop?
Okay. Okay, good. I'll go ahead and start. It's a good question. I agree totally that it's almost more than we can address. But it's like anything else. I think you need to sort of down select or prioritize those things that need to be solved first to enable long-term exploration, and focus on those. And while you're doing that, also focus on engaging, again, whether it's an international partner, academia, a particular space agency, particular area that's doing research in that area, that focuses on those prioritized systems. We could stage, and again, we have certain commercial folks out there who are ready to stage a Mars mission today. It's just a matter of that in terms of what do you need to focus on to enable a longer term exploration beyond low Earth orbit. So in Larry's estimation, the most important are the life support systems, the EVA capability, and Lindsay looks at me really with amazement. But yes, so those core capabilities are, I think, essential in exploration.
For the yeah.
Push the button.
Okay. Yeah. In Japan, actually, we space agency are now collaborated with commercial sectors, and but as a scientist, I have a little bit of concern because if commercial-based private sector go to the moon and they use the moon, but sometimes they pollute the surface of the moon and inside the moon, and there are a lot of the things for science on the moon remain. So the space agencies should lead the moon exploration from the viewpoint of the science and the new things to be known. So and of course we need a collaboration with the private sector, even some private ones. But space agencies should lead the rules, should make a rules, and should the policy and what kind of science should be done. Because science sometimes do not return to any economic something. But we humans need science knowledge from the moon and from the Mars and from the space. So that we space agency and the private sector should have each own roles, I think.
Thank you. Another question?
This is easy.
Sounds great. Thank you.
Okay. Okay. If no one else is asking questions, I will. So Larry, on the Lunar Gateway, I am, aside from many other things. Oh yeah, I'm sorry. Aside from many other things, I'm an officer in the National Space Society. And the advocate community has been concerned, I'm sure you know, about the costs of Orion, the costs of SLS. And there's a board member of National Space Society, not me, who's concerned about what he was calling now the Gateway. One of the concerns we have in the advocate community is we certainly see a need for a lunar port, a lunar orbital port. I've been advocating this for years. We're getting rumblings that the intention is not to have this continuously occupied. So is it capable of continuous occupation? Eventually, maybe there won't be a need for continuous occupation from the beginning, but to be useful as a port, needs to be continuously inhabited.
Yeah, so that's a good question. The way to sort of address it most directly is that the initial missions to Gateway, the capabilities that are being provided are modular, and that's basically based upon the payload restrictions that we have utilizing SLS, although we're starting to enter in using commercial launch vehicles as well. But its initial capability will be for 30 days for a crew of 4. initially over an entire year. So there's two ways to look at that. One, capability sustained people there will be grounded from the start, okay? As time goes on, and the idea is that missions would then increase in duration as you're able to provide additional capability to it. The second part of that, which I think is very important, is that autonomous period that the gateway will be without people in it will actually force and drive, again, I mentioned it in my talk, the autonomy of the vehicle or of the location, of the, I guess you call it, it is a vehicle, but the autonomy within the vehicle so that it's actually continuing to conduct science. It's able to do a lot of those things that we will need to learn from, but without crew being there at all. Right now, again, what we're starting to incorporate into the idea of the gateway is that it is a port. So we're doing our best to limit it to not become a smaller space station, which is the basis of your question. We've been asked it a number of times. But what we're trying to do to enhance the capability of it being a port that allows access to the lunar surface, suddenly you start having to provide interfaces and capability for landers, let's say. What type of science that you do from there, maybe using CubeSat approach to where you're able to use an airlock that's provided, but not only for people, but for launching payloads. So, and again, the overall vision for the gateway is the first step of that space directive. It has to provide a sort of a port, as you called it, but it's the first step in that. And it has to enable, and we're not losing that in the focus, it needs to enable that long-term, your mission to Mars, is that's possibly where it will be assembled, possibly where you even send the gateway assembly to Mars, let's say. I hope that kind of addressed your question, sort of. Good. And Dan?
Well, and if I may just real quick, is what Larry said earlier is important, and that's priorities, because it's going to come down to understanding what the priorities are, what the research priorities are, and what needs to be done when, because none of us are going to get enough money to go do it as fast as we want. So there will have to be some hard funding decisions made along the way, and that's going to be based on what the research priorities are and what we're learning, and how that knowledge affects the architecture decisions that NASA and other people have to make.
I have comments for this question. Actually, following or along to the consensus of the space agencies, and we JAXA, of course, trying to involve in the gateway, deep space gateway mission. But even in the JAXA or in Japan, some people are very concerned or complain because in 1990s we started to establish to construct a space station, and in those days, in Japan, the main purpose of the space station is to make dream medicine against the AIDS or the space very great high quality materials, but even now, we Japanese people do not have any information about such a success of such a making something. So the actually International Space Station needs a lot of money, and we Japanese people should pay the taxpayers should pay the money, so that they need some return from the such a space station construction. I think in United States, this country has a pioneer mind and understanding to the science. But in Japan, sometimes economic return, all the people need such one. So that we should make some return from this space gateway or lunar landing mission. So that now we should consider a lot of things. And some people think this is just a gateway to the Mars or to the on the surface of the moon. But some people think, of course, direct go to the moon, Mars is better, and directly landing on the moon is better. And on the around the lunar orbit, there are a lot of radiation, so not so many people are not so long day staying could not be can be difficult. So that we should consider and we should openly discuss this deep space gateway successful using. So that we should not hesitate to discuss. If we hesitate to discuss everything, then we made a mistake like nuclear plant in Japan. You know that in Japan sometimes we scientists did not discuss so much for the safety of the nuclear plants, and we did not discuss provide any real scientific information to the ordinary people, so that we should not hesitate the open discussion, and then we may have many problems, but if we even ordinary people understand the problem issues and the difficulty, then we decide to go to make this one or to go to the moon or Mars. It's okay, but if we hide such a clear discussion, it's a very problem, I think.
Okay, we have 5 more minutes, so I'm going to say 2 more questions. We had one here, and that was the second. Oh, sorry. Okay, we'll go 1, 2. 1, 2 instead of 1, 2. Okay. Oh, go. No. No, go ahead. Go ahead and ask your question. Yeah.
Okay, I have, first is a request. I don't know if the group will find it helpful, but I would. During the breakout sessions, it would be very nice to have a few copies from some of Larry's slides, particularly the ones that refer to requirements for the habitats. So if we could make copies and just make them available at the 3 breakout sessions, that would be very helpful. And the second one is something that Dan said that it excites me, which is I'm an engineer. And so data for me is very important, right? And he said, you know, we need engineering data. And in the presentation from JAXA, we saw some examples of what kind of data would be helpful in order for us to go from the station that is there to the surface of whatever body we're orbiting. So I'd like to ask the panel, in their opinion, where are the gaps in data that we need to or should be addressing? And I'm sure there are priorities, but it would be a great suggestion for us as we have our discussions to identify where is the need of that for that engineering data.
If you want to start.
Yeah, you probably ought to start.
Okay, I'll go ahead and start. Thank you for suggesting the charts. I think they would be very helpful. So the gaps, let's see. I think the primary gaps as we have it right now from an engineering standpoint is to revisit how I think getting there, like doing Gateway, going to Mars in a zero gravity environment, I think we got, right, in terms of technology in a way. I think where the gaps are is understanding how does that particular subsystem, let's say fluid dynamics, how does it change from the zero gravity environment to something on the moon or Mars related to a life support system, let's say. What that life support system includes, like includes, I would say, gaps that relate again to life support. Food system as a very big example here. To enable a 3-year mission to Mars, staying on the surface and back, 3 years. That goes beyond our current food system shelf life. That's huge. So how do you incorporate additional things such as growing plants? Again, I mentioned it, maybe having aquaculture or something as part of that. I think the gaps, and I'll answer it sort of in a generic sense because I can go on and on, but is looking at systems more in an integrated way as opposed to an isolated way that we've done on station. Again, I tend to deal with describing things as bioloops. So how does the life support system, integrate with the stowage system, which integrates with the 3D printing? So in other words, as an engineer, looking at things not so much in an isolated way, but more in an integrated way with other subsystems.
So, Julio, I'm going to pull back on some of my previous life, which is, oh shoot, I'm outside. I don't have a green light again. Here you go, Dan. Let me go back. I would point to some documents that are out there and some thought process that's already been put into this a little bit. One thing I would really highlight that we as engineers don't like to talk about a lot because we like to go do the cool stuff, and that is the reliability that has to be brought into these systems from the very beginning. We are dealing with with a set of environments that we don't totally know how to deal with, and yes, we have experience 200 miles up. Yes, we have experience for a few days on the moon, but we're desperately short of experience in these environments. And so we need to think about understanding the environments. We have to think about the reliability that's beholden, that we have to address. And then, if I were king for a day, I would point us all back to the National Academies has actually done some pretty good work on a lot of this. NASA's done a lot of good work, and so have the National Academies in terms of the 2014 Pathways to Exploration report that doesn't get into technical details, but it tries to lay out a framework and an approach that I think ought to be considered in all of this. And then the National Academies, to go back to what Larry was hitting on, and what we need to do in microgravity and partial gravity, from fundamental physics through fluid physics through the psychology of all of this. All of these aspects need to be addressed. When you were asking the question, Julio, I stand back and I look at it and I go, I'm almost of the opinion that we almost don't have any data, because we really haven't been, this is exploration, so we don't really know, so we have to go figure it out. We have some data, we have some experience, but it's a small subset of what we really need to go do all of this. And so the ground is fertile. I think one of our hardest problems is going to be getting to what are the key questions we need to answer and what are the priorities.
From the viewpoint to explore the lava tube, and there are a lot of I'm a scientist, so I don't know the engineering aspect so much. But I sometimes discuss with engineers, and there are a lot of the difficulty issues for the engineering side. And first point in Japan, landing. Landing technology is, we need anyway landing technology. And actually, the United States have already achieved the landing technology on the moon, but that is 50 years ago. And now only China have such a landing technology. So the Japanese and other countries should learn again the landing by itself. Of course, Martian in United States could achieve many times for the Martian landing, but a little bit different between the difference between the Martian landing and moon landing, because there is no atmosphere on the Mars, on the moon. So anyway, we should again try to land on the moon, and very accurate landing technology should be done. And the next point, if we make a habitat or lunar base in the lava tube, there are 2 points we need technology aspect. One is energy. Actually, inside lava tube is minus 20 degrees Celsius. So perhaps for the instrumentation machines, no problem. Minus 20 degrees night, it's okay to keep. There is no heater. But if they need, if we operate the instrument, we need energy inside lava tube or or if we humans go to the lava tube, minus 20 degrees are a little bit cold, so that we need some heaters. And how can we get the energy? Of course, radiation, radioactive nuclear something, but can we keep the solar energy in night? So that's such a technology we need. Final point is recycling system. Perhaps if we humans go to the inside lava tube, or if we operate on the surface of the moon, how we how we recycle water, materials, and something. And we should abandon the entropy, and we need energy. So such a recycling system that we should keep. We should get such a technology. Of course, some Japanese companies are very, very interested in such a recycling technology. But how to establish such a one is a point, I think.
Thank you. So I promised a question. We've gone 10 minutes. Do you want to ask a quick question? Can we do that? Okay, thank you.
Yeah, so we're talking a lot about habitats, a lunar deep space gateway, going to Mars. We should also be thinking about, this is more of a comment because we didn't really talk about this, the infrastructure that precedes that. If you're going to be putting astronauts up in orbit around the moon, you're probably going to know if there's radiation events that are heading their way so that they can take shelter. Investment in communication structures. I mean, we can't always rely on the Mars orbiters to relay satellite information back all the way to Earth. We might want to put in some infrastructure. So, I mean, I don't really have a particular question, but more of a comment that we should be thinking about those kinds of things that would precede these kinds of missions. So,
Thank you.
Put out there.
Excellent comment for the breakout sessions, for the coffee break that we have right now. So let's take a 10-minute break, come back at 10:35. So it's really 9 minutes, sorry. Thank you very much for an excellent session.